Here we are at example 4 from our 4.1 set of notes. We're asked, what is the derivative of the sine of x? Well, though this might seem a little bit trivial, it's actually going to help us out quite a bit when we start talking about some of the things like the antiderivative. The derivative of the sine of x, which we know from last semester, is just the cosine of x. And as a result, then we can reasonably assume that the integral of the cosine of x dx is going to be equal to the sine of x, if we're working backwards, plus some constant. And that's pretty much what we're going to be talking about when we're doing the reverse derivatives. So when we have the antiderivative of x raised to some exponent, well, that's just our power rule that we've been seeing. So that's 1 over r plus 1 times that variable x raised to the r plus 1 plus some constant. The antiderivative of the sine of x comes out to be negative cosine of x plus some constant. The antiderivative of cosine of x just comes out to be sine of x. We've already seen that a moment ago. Plus c. The antiderivative of the secant squared of x comes out to be tangent of x plus c. The antiderivative of cosecant squared of x dx comes out to be negative cotangent x plus c. The antiderivative of, well, actually, we'll come back to this one. We'll go back up because I'd really like to talk about these two together. The antiderivative of the secant of x tan x comes out to be secant of x plus c. The antiderivative of cosecant x cotangent x comes out to be negative cosecant x plus c. The integral of e to the x dx is just e to the x plus c, just like it is with derivatives. The antiderivative of e raised to the negative x, it's pretty similar to this one, only we still have the e raised to the negative x plus c, but along with that we do have to apply that negative. And lastly, moving on to these last three. If we recall back to derivatives, when we were doing inverse functions, we may recall that this one actually comes out to be the sine inverse of x plus c. If you have the antiderivative of 1 divided by 1 plus x squared dx, well, that's actually paired up with our tangent inverse of x plus c. And then lastly, we recall back to chapter 3 when we had the one with the absolute value. That was the secant inverse of x plus c. So again, before we had like the derivatives of these, so we would try and take the derivative of this inverse function, and it came out to be this function, 1 divided by the square root of 1 minus x squared. Now, though, we're starting off with this and moving backwards. But hopefully seeing some of these should refresh the memory. Again, though, that is example 4 from our 4.1 set of notes.